So now it is time to dive into our hands-on session. In this session, we are going to learn how to program robots using the Rust language. Rust has been defined as the language for robotics developers with the efficiency of C++, but without the hassle of having to keep every small detail during the compilation. So our next speaker is going to teach us the basics of programming ROS with Rust. Júlia Marsal. She is a robotics developer and also is a robotics consultant. Today, Júlia will guide us through programming ROS2 with Rust. Welcome to the conference, Júlia.
Hello, can you hear me?
Yes, we cannot see you. Ah, there it is. There she is. How are you doing, Júlia?
Fine, thanks for the introduction. Thanks for inviting me to this learning session, and congratulations for the overall event. That it's awesome.
Thank you
With
very
this
much, Júlia.
excellent
Thank you.
speakers that we have today, and I think that's awesome. Congratulations to you.
Thank you. And you are part of it. So thanks a lot, Júlia. Thank you. Then, are you ready for your presentation?
Yes.
Then let's go.
Okay, let's go. Welcome everyone. Welcome to the ROS2 programming ROS2 with Rust session, skill learning session. As you might know, Rust it's on the date, it's up to date. So what is Rust? Rust is a language that empowers everyone to build reliable code and efficient code by default. And Rust 2, as lots of you know, is a system framework for robots. And now ROS contains the possibility to be defined design with Rust. So what we're gonna do with this project, what we are going to learn is how to develop Rust nodes with a real robotics applications. How we're going to do that? So first, we're going to see what is and why we're going to use Rust. Then how to install Rust with Rust 2 if you want to try in your own computers. After, we're going to start to see how to move a robot with Rust 2 and Rust, so how to get our hands deep on a real application. To do this, we're going to create first a Rust ROS package. Then we're going to learn some basic Rust programming tips. After that, we're going to see how to create a Rust subscriber, then a Rust publisher, and then how to create a node that contains a subscriber and a publisher at the same node. It seems easy, but it's not as we think in Rust. Then we're going to see some feature works and the Q&A session. So, who am I? My name is Júlia Marsal, and I am an industrial engineer with a master's degree in robotics. When I started and I looked at what to study, I didn't see anything about robotics. So why my first step was doing like an industrial engineer degree. After that, I saw that my role in life was to be a robot engineer. So what I did is a master's degree that I really encourage you to do it if you are like thinking about it. And where I really learned a lot of things, I learned a lot of ROS that I really loved it. And until now, what I've been doing is I've been in different universities, developing some projects and also some companies, developing some custom robotics applications, mostly in ROS. So this year I had the opportunity to start my own like brand that is called JM Robotics. And what I'm doing now is I'm a robotics engineer consultant developing software for DTE. DTE is a company, it's a robotics company. It's located in Iceland. And what this company does, it produces applications for the metal of the future, robotics applications. And in addition, few times I've helped studies teaching robotics and also for different universities and companies on demand, which I really, really love it. It's one of my hobbies. So please don't hesitate to contact me if there is anything further I can help you. And this is my LinkedIn profile. So what is why Rust? Maybe because it's becoming famous? No, that's not. Rust is a system programming language that it has designed for performance. By default, the way Rust has been designed is that when you are developing code, you are thinking about performance, safety, and concurrency. So it was developed originally by Mozilla in 2006, but now it's maintained by the Rust Foundation, which contains some open source parts. So the main characteristics or feature of Rust it has a really good tooling where it's easy to work with Rust because the tooling that it has is a really good develop. And there's also the error management. It has its own way to manage error, but I think that you will love it. You're gonna see in some time. Concurrency, it allows you to execute some part of the code independently or in a concurrent way. It's designed thinking in memory safety. So when you are developing, you are thinking in memory. Type safety is a type safety code. The community and the ecosystem, it's really high. And there is lots of people. And also it is really easy to ask in the community if you need any help. Documentation and learning resources, it has its own website, and I think that I encourage you to look through it because it contains its own book, and I think that it's really, really, really good, and I encourage you to look through it. So ROS 2, by default, when you install ROS 2, it doesn't contains the ROS package. So the only way to install the ROS 2 package, the main one, now it's using the repo. So you have to clone the repo and then install the package, okay, with a calcin build, and it's gonna do its magic. So also it contains a Docker file if you don't want to install it. I think that you need the version of Humble 20.04. But if not, it also contains a Docker file. So I really encourage you to go to this website, look through it. It contains indications how to install it. And also it contains a lot of examples that you can also look through it if you want. So what we are gonna do here, we're gonna move a robot with Rust 2 and Rust. Which robot? Here you have a simulation, okay, that you can open it. This is a awesome simulation. It has a grocery store, I think, but I'm not sure. Go, okay, if it allows me. Okay, so so here, if we go to here, we have our friend that is at Ultrabot 3. And here we're gonna work with this simulation and with this robot, the Ultrabot 3, that is here. So if we go again, we can open our notebook and also our terminal. I hope that you have finished the overall build of all the packages. And as I told before, there is the packages has been previously downloaded, cloned this repository, and you can find it here. Okay, so it's here, the packages. So how to create a Rust ROS package. Okay, in Rust, the cargo it's the Rust package manager. So every time we want to build, we need to use the cargo word, okay, to create a new package, cargo new, and there are different kind of shortcuts that we can also use it. And the crates itself is the name that Rust is the name of the packages of the Rust. So crates, it's packaged in Rust, okay? So there is a website, it's this one that you can enter, and you can see the overall open source packages, or crates in this case, that Rust contains, okay? Not all ROS packages can be found, well, it's here, you cannot find it, but the main one that is the ROS2 client library for Rust exists. And we are gonna use this crate as the one that Rust contains by default. So we're going to install and get it by Rust, not by Rust 2. So we are going to use this one. So what we're going to do, first, we're going to create a new crate, okay, new Rust package. We're going to open a terminal, okay. So here, what we have to do is this. First of all, go to the source file folder from Rust 2 and create a new Rust package. So enter, and then I have a new package, okay, here, that it's called Wandering Behavior Rust. What does this package contains? This package, if I go inside of the package, okay, contains the cargo.tone file. This file is similar to the CMake list as in C++. So it's the file that contains all the dependencies, metadata, and compiler settings. Okay? And if I go inside of the RC, I have a main.rs file that it's created by default, and it contains some like program that by default Rust does. Okay, and it should print hello world. Okay, so we have seen what we have inside of the create after created one. But now we need the package. Okay, we need to create a package. Why we need to create a package? Because we have some packages that is like in ROS side, and we want to create a cargo crate. Okay, and we want to link between ROS side and our Rust package. So that's why we have to create a new file, and it is gonna call the package, as we may know from ROS. Okay, so here I have my package, and I'm gonna copy this and paste it here. Okay, I'm creating a package that is called Wandering Behavior Rust, the same name as our crate, and the description and the dependency, and also the amen cargo. The amen cargo, what it's gonna do is like to make the link between ROS2 and our package. Okay, when you are building. Okay, so what we can do now is like compile this like package and then compile it. Okay, it's gonna build the package that we've just done. And then we have to install, because it's a new package, so we have to source it. Okay, so Rust. Rust, the way that they have think about by default is a language that by default, when you are designing it, you are thinking about memory without knowing it. Okay, so this is the basic Rust programming tips. Okay, we are gonna see this through the examples that we're gonna see now. So you can see how to create a node, how to create a subscriber, how to create a publisher, the spinner. Okay. So how to create a ROS scan subscriber. What we're gonna do now? We're gonna open again the terminal. And we're gonna connect with the current robot that we have here. Okay. And we're gonna see which topics this robot does it have. So we have these overall topics. So the CND bell topic is the topic where we are gonna talk, and what we're gonna do is like command the robot around the simulation. And also we're gonna talk with the scan topic in order to get data from the scan, the LiDAR. This is a LiDAR. Okay, so the LiDAR, what it does, it detects in which distance, in each angle, it has some object. So first of all, what we are gonna do is to create a subscriber to the scan topic. Okay, how we're gonna do that? Yes. First, what we're gonna do is to create or change the name of this file. Rename. And this is not the right one. You have to use this one. Okay. You have to change the name. Okay. And copy this overall code and paste it. So what we have here? Here we are importing some dependencies from other crates from Rust. Okay. Standard environmental crate or package. Anyhow, that contains the error and also the result crates, which you can see that before we have seen that it has its own way to handle errors. So this is like how the function returns success. If it's success, it's gonna return this. If it's an error, it's gonna return this. So error handling, it's a bit different that we are used to it, but I think that it's awesome because we can define its own custom errors. So this is the main function that we are going to execute, and this is what the type is going to return this function. So context is like the variable that which like interacts between the other nodes and shares states and data from other nodes with the current node. The node, we are going to create a ROS node, passing through reference the context, and then this is the name of the topic. Sorry, the name of the node. Okay, so this is how we create a node. RCS is what we have seen before. It's the ROS client library for Rust. And here you can see what I said before, that when we are developing, we are thinking about the memory and the efficiency. So by default, Rust variables are constants. So if you don't want to change, you don't have to do anything. But if you want to be mutable, you have to put mute in the front, okay, in order to the variable to be mutable. So this is an unsigned size, and in this case, it's equal to 0. This is a subscription. We're going to create the subscription. So the same node, we are using the function create subscription. And this is the type of the message that we are subscribing to. This is a laser scan message. That this message, it comes from Rust 2, okay? Not from a crate from Rust. So the scan is the name of the topic that we are subscribing to. This is the quality of services that is, we are using the default one. What moves does is converts a reference to and gets its value. So yeah, we're getting the value from a reference. So here is the message that we're getting info from the scan topic. And here is the type of the message. As we have seen before, we are increasing the number of message every time we get a callback. And this is, we are printing some properties from this message, okay? This question mark, what it does is, if this function is success, it will return what the function itself returns. But if it fails, what it's gonna do is propagate until main an error, okay? And then spin is, we need to call it in order to call the callbacks. And here we are mapping the errors depending on its type, okay? So now we have the code, we have the main, we have the node, but we have to define the dependencies of this node. So first we have to tell to the package and the ROS2 that we need some package that there is in ROS2. So we have to add a dependency in the package. Okay. After that, we also have to say to the crate itself that it is one package that it's called sensor message that is needed. So we are going to the cargo tool and say, okay, you need this message. And also we need to tell where is the file that it has to compile and create the binding. So we have to tell to the crate where to find the file and compiling it after or whenever you want to build it. In order you to know how to add crates inside of this crate, there is another way. If the crate exists inside of Rust, that you can make cargo add, okay? And then you have to go to the package or crate and then add it, okay? It's adding it. This is that it's like telling that the sensor message doesn't exist because it doesn't exist in the crates. And then we have to add the RCLRS that we are gonna get it from also from the crates that Rust contains. Okay. So after that, we've got a package and we've got a node and we've got a subscription to a topic, to the scan topic. So what we're gonna do is to build the package using ROS2 call build dependency. Okay. So we are going building Rust package with using ROS2 tools. Okay, so I'm gonna continue because it's gonna take a while. After this, what we're gonna do is to execute it and see what we get from this node and what we get from this subscriber. And the next point will be to create a Rust publisher. So what we're gonna do now is to publish to the CMDevel topic and make the robot move around the simulation. So just finished. I'm gonna source it first, and then I am gonna execute it. So I'm running it. Okay, so what I'm doing, I'm getting its info from the robot, and I'm getting the distance from the range in a specific angle from the robot. This is the minimum angle and the angle max from the robot from the LiDAR. Okay. So next point, we're gonna command the robot with a Rust node. So we're gonna create another file. Okay, this file is gonna call cmd Bell publisher. Okay, we're gonna copy this overall code. So here we have almost the same as before. We have the standard environment as pack or create as before. We have the error, we have the result as before, and we are like calling to the twist message because we are gonna use it to publish to the CMDevel topic. So first, the same as before, create the context, pass by reference, creating a new node. And then when we have the node, we are gonna create the publisher, different function. We are passing the type of the message. This time it's gonna be a twist. This is the name of the topic that we are gonna talk with, and the quality of services default. We are using the default one. So here, as you can see, we have the CMDevel message. That is the message that we are gonna publish to the robot, and we are gonna creating a default one, like just initializing it. We are creating mutable because we want to change it. The idea of this code is to create a pendulum movement, okay? A movement that it changes. In each publisher, you change the velocity in order to not let the robot crash with a wall, just to have the robot controlled. So here is the velocity. It's a value that we are gonna change, and this is the message that we are gonna publish. So we have a loop, and on every loop, what we do is changing the message type and changing the message and changing the velocity. Okay, so with the velocity, it's less than 0.2 meters. We are like putting it positive in order to go to the strike, okay, to the front. And this is changing the velocity in each loop, depending if it's not this value, it's gonna change it. Every loop, we publish the message, and then we sleep. Okay, this is the thread that puts the thread to sleep, 500 millis. Okay, as before, if everything works as expected and there is no error, it's gonna return awk. Okay, or it's gonna return awk always, this kind. Okay. So that's it. In order to also to define the geometry message that the CMDevel topic needs, we have to add also in the cargo.tolm in order to tell that we are gonna use it. Okay. And what we have to do also is to create the executable. Okay. Also, we need to talk with those two packages in order to tell that we need this kind of package. So we need to change it in the package itself. Okay. And then we are ready to build everything. And then let's try to move it. Open the gazebo. Open the gazebo. Okay. And let's move this. Now. Okay, let's see. The robot goes to the front and then decreases the velocity, goes to the back, decreases the velocity. So it's moving. We are able to move a robot, changing the velocity from the robot. Okay. So now what we have, subscriber to the LiDAR and publisher to the CMD bell. So what we are gonna do now is to change the subscriber to make a note that it's gonna do the obstacle avoidance. Okay, so if the LiDAR detects some object, like now, it's gonna try to avoid the object, changing the velocity in the other direction. I highly recommend you to reload, okay, because in the next node, we're gonna use it and to stop it, the simulation. It's this one. Okay. So why I think that it's so important to you to see how to integrate two nodes or two kind of topics in the same file. It's because in Rust, as Rust is a language that it has been designed. When you are programming the language itself, you are designing the code in the best way in regarding memory. So sometimes they're not. We have to think about how to do the things in the best way. So if we look through to this code, what we're gonna do is an obstacle avoidance. Okay, so we're gonna copy this code first, creating a obstacle avoidance file. Okay, so let's create a new file and copy this. Okay, so let's copy this code and paste it here. Okay, so what's the difference in this code? Why it's so tricky? First, what we have to do is to add the same variable as before and the arg. The arg create, what it does, it it shares the ownership of the data between multiple threads. As we are gonna publish and we are gonna subscribe, so they need to share data. So we need the arg create in order to share the data. Okay, and we need mutex in order to know if this data is logged or it is used by other threads. Okay, so yeah, same message as before, type of message, same message as before, and here is the same types as before. Okay, here what we have here is here in Rust, classes doesn't exist. Okay, what it exists is the struct. Okay, so in Rust you are able to define and implement structs. Okay, so this is a definition of the struct. Okay, this struct is called obstacle avoidance, and this is a property of the struct that's going to be the subscription, other property that is going to be the publication, and other property that it's going to be the twist message. Okay, that this twist message is going to be shared between the publisher and the subscriber. So here we'll create an arg, an object that shares the memory, shares the data, and of type let's rescat. We're going to create a subscription, and here we're going to create the publisher which contains or which is based on this type. So here is this message. That is the message that we're going to share between the subscriber and the publisher. And this one, we have seen this. So we're going to do now is to implement this struct. So we're going to implement the functions of this struct. So the new is it's like in the C++ we have the constructors. So the new is a constructor. Okay. So in this case, this constructor has a node that we have to pass by reference. And what this struct returns is self, the object itself that is going to have these properties. And also what it have is this is an error that it has been defined in the ROS client library. So you can see that the errors can be you can create over your errors if you need it. So what we're gonna do, we're gonna create the message that we are gonna share, and we are gonna publish as an object. When we are gonna return it. After, yeah, this is how it does. We're creating an user object, and this we need to create a mutex of this object because we need to know if this object it's used by other thread or not, and the type of this message is a twist. Okay, we are creating a publisher, so it's the same as before. We create a publisher of type twist. It's the same as before. Maybe I can do it bigger. Okay, so yeah, it's better. Same quality by default. And then what we have to do is to create a clone message. Okay, why we have to create this clone message? Because there is something deep in Rust that this object needs to be returnable. Okay, because it is like when you return the object, you need to return it. So you cannot like it's kind of ownership, but you cannot like use it. You cannot like change it inside of here. So what we have to do is to create a clone. Okay, so you have to create a clone of the message to be able to lock it inside of this subscriber that we are gonna do it. So we are passing by the reference the twist message, and we are creating a clone of this message. Here we're creating the subscription, the type of the message, the scan is the name of the topic, the quality of service is the default one, move, we're passing by value, this is the type of the message that we are changing. And here, what we get is the different distance in each in each 90 degrees. So this is the 0 degree from the LiDAR, this is 90, 100, 270. We are printing this distance that we are getting from the scan topic. And here we are changing the velocity depending on the distance. So we are able to make the obstacle avoidance depending on the distance that we get in each angle, okay, that we have seen it here. So if in the front I have some object less than 0.5 meters, I am gonna go back the linear velocity in x, and then I'm gonna turn a little, okay? In the right, I'm gonna turn a little to the front and then spin, okay? So depending on the distance that I get in each quarter, I have a different behavior, okay? And if everything works as expected, I only go straight, okay, with this velocity that it's always in meter seconds. So it's in the international system. So if everything works as expected, here I have this question mark that also says if there is any error, this error in this subscription, it is gonna propagate to the new. So it's gonna return an error. If it's not, it returns what this function returns, that it's gonna be in this case, I don't know, but I think that it's nothing. Okay, so it's gonna go to the next step. If everything was as expected, we return an awk. Awk, it's an object, or it's a type of object of Rust, and we always return an awk, and this is the payload that we want to get, the self. Okay. Yeah, the awk, it's always this, more or less is what it has here. And we return the self because it's okay, so we return the self. Okay, so we have another function that is a publish function. So what we'll pass the object by reference, the same object that we are working, and here is the message that I am getting. Okay, I am locking it, and I am getting the message. Then wrap means if everything works okay, it's gonna return the payload. But if there is some error, what it's gonna do is crash the program. Okay, with what unwrap does.
Julia,
So
5
here,
minutes.
okay. So then, yeah, we make the publisher. Okay, we pass through by reference this message, and we publish it. And then the main function is the main code. So we return a result, and if it's okay, it returns nothing. If it's an error, returns an error. So the context, same as before, node same as before, name of the node, and yeah, we are passing through the node, okay, by reference, as we have defined in the new function, okay, here. And yeah, it's a while. So every loop we publish the message, because we can only call the function that we have here. We don't need to create a specific stuff, so we can call it. And then we spin once because we have a loop. We pass the node, and then we spin, and we have a duration of 500 millis to give some time. And then we sleep the publisher. So in order to be a little slow. And then, as we have defined here, the result, we return okay. Okay, we are gonna return okay. So that's it. If it fails, this it's gonna fail. So it's gonna like return error. Okay, it's gonna propagate the error. Okay, just to finish. In this case, as we have imported everything before, we just only have to create the executable. So we have to go in cargo tool, create the executable, okay? And then we are ready to build it. Okay. And then we just can run it. Let's see what it does. First, open the simulation in case. Okay, it's gonna avoid it. Yeah, it's avoiding. It's a kind of simple explorer. So he's gonna go around the simulation. Maybe it's gonna crash here because the LiDAR cannot detect this. No. Okay, that's it. That's it. You have an example how to create a publish and a subscribe in the same node. That for you, it's really awesome. So future work. You are now prepared to build nodes in Rust. To further enhance your proficiency, I recommend you reviewing the following courses. Yeah, it crashes. So let's stop it.
Excellent. Julia, thank
Not
you
the
very
best.
much. Thank you very
Yeah,
much.
here you have some documentation if you want to look through it. I really encourage you to look through the ROS documentation, and also to look through these courses. Thank you so much, The Construct, for inviting me, and for your time, and for your assistance.
It's our pleasure, of course. So thanks to you, we have an introduction to Rust for ROS too, which is something that is lacking in the whole world. So thank you very much. Then let's go for the questions. Okay, are you ready?
You're welcome. Yeah.
Yes. So for the audience, you can put the questions for Julia on the questions and answer tab that is on the chat, or vote for the ones that are already there. And I will be asking the questions that are most voted to her. Then let me, in the meantime, Okay, well, I have one here, but here there is another already some questions. So it says, would you say that the ROS client actively is maintained to a degree that it can be used in production?
Yes, if you look through the Crates website, have been a lot of releases of this package. So I think that it has really improved it, and I think that it can be used in production because it is the main node and it has been developed a lot. So I think so.
Okay, and also there is a team, right, developing behind that that are in charge of improving and maintaining the ROS packages for ROS.
Yes,
Yes.
that's it.
Okay, then what can you say about performance? So that's a question from Sachin Kumar that says, how is the performance of Rust compared to C++ and Python?
Okay. It's a really good question. Um, I've I've looked about different people that has done some performance tests, and the conclusion always was that Rust it's a really good regarding performance, and but I think that if you are a really good C++ programmer, you could know how to improve the overall code to be
More
to be the
efficient.
best in. Yeah, exactly. But Rust by default is what I love. It is by default that the curve of education as a student at the beginning may be difficult if you're not a programmer or have a software a programmer or have not software programmer background. So, but I really encourage you because by default Rust teach you how to program regarding efficiency, memory safety, and that's why I
So
think that
at the same
by
time that you are,
default it's defined.
yeah, so at the same time that you are learning the language, you are learning how to do it properly, how to use it properly.
Exactly, that's it. And you're learning more regarding software engineering. Yeah, that's it.
Okay, interesting. So did you know that the Open RMF framework, which is the fleet management system for robotics, which is made by the ROS team, then that this is being changed into Rust, is migrating from C++ into Rust. Did you know that?
Yes, I know that. Lots. I every day talk with lots of things, and lots of people are thinking about migrating to Rust because my point of view as a robotics engineer is that it contains really good things. Maybe they have studied about different kind of languages, and they have in Rust they have picked the good of every language. So in Rust, you can like define smart pointers. You can define, for example, the strings that Python contains. That it's really nice to handle strings. So Rust contains it. So this is my point of view that people loves it because it contains the more or less the best of each language.
Of both worlds, of all worlds.
I think so.
Okay,
Yeah.
okay, interesting. And then what I wanted to ask you, yes, because before you, we were interviewing Luca Marchioni and Sai Kishore from PAL Robotics, and they were mentioning about one of the possible drawbacks of Rust for being used into robotics, and it's about the how many libraries do exist that can be interfaced with Rust for robotics. I mean, so what do you know about that? If there exist
Okay.
many libraries that can be used, because in Python we have everything. So for processing images, we have this. For I don't know computing trajectories, we have this. Matrices. What do you know about the available set of libraries for Rust?
What I can say that the Rust community is increasing and it has a really good developers. And I have seen, if you look through the crates, for example, the standard message exists in the crate, but that has not been approved yet. So people are designing code to ROS. So maybe it's not delivered and it's not available now, but it's gonna be I don't know now or in the next few months, but it's gonna be. They are working on it, so they are people who are developing it.
Okay, okay. So yes, it's work in progress, and then there is progress,
Yes.
which is
Yes.
important. Which is
That's
important.
it.
And then what about which things are not supported now in ROS 2 with Rust?
What you say not supported, I would say
Officially, let's
you
say.
officially with the crates when okay, if you download the package and you build it, you go to the GitHub and download the repository, you can build and you have lots of basic packages and not as basic but that you can use from Rust. But inside of the crates, as far as I can see, the standard message are not included yet, but it's included but not accepted, so they are working on it. The geometry message also. So you can work with Rust now with the package itself, with the ROS packages, but I don't exactly know which are not exist. But I think that with you can program with Rust now, but using the ROS packages downloaded by the GitHub repo. Yeah.
Okay. Okay, I have a question here from Rodrigo that he says, I've never worked with Rust, but the one time that I did, I was having trouble with my workspace finding basic standard messages dependencies. Is this because I have to install it through crates.io?
No, if in the current project you had problems, means the standard message should be in ROS side, so it is strange because it is using the ROS package standard message.
Okay, so must be something else that we cannot debug now, yeah?
Could be that he cannot include or he didn't include in the cargo tool because it's a dependency that the crate needs. Or it could be that it also has to be added in the package dot XML because there we are making the link between the package that ROS like finds with our crate.
Okay, makes sense. Making a lot of sense. Okay, I have one question here, interesting, from Sorawit that says, what is the difference between the two crates, the ROS2 client and RCLRS? It looks like there are two crates. Which one did we use here today?
RCLRS.
Okay, so it looks like there is another one called ROS2 client.
Oh, that's a really good question.
Okay.
I don't know.
You don't know. You don't know. Okay. Okay. Yes. Okay. So that's okay. And then here there is another question here from Angel Lopez that says, I've never heard about Rust until a couple of months when the construct created some courses and live sessions about it. And then he says, why it is becoming so popular all of a sudden?
It's because the efficiency that Rust has and also the memory, how it handles the memory, its memory safety. So by default, it's a bit tricky at the beginning, but after you are designing code that it's gonna be safer and regarding memory and performance. That's why people love it.
Okay.
It has been used in robotics and also in like lots of developers use it for different applications.
Okay. Okay, then. So we have another question here from Ruben that says, Rust claims to be memory safe. In C++, we could achieve the same thing using shared pointers and the threads, right?
Yes. Okay. What Rust have, it doesn't have a garbage collector. Okay. What it does is every time you create a code, the compiler assigns to the memory the size of the type of the variable you are using. So the memory, it's always there is the stack and the heap. No? So in the stack you have all the variables, and you know the size of each variable. Okay, so if you want to use pointers, you have to use the heap because you are referenced as a pointer. So it's another way to handle the memory. And I have really good conversations about this. And what I can say is, by default, Rust makes you think about the memory. So it's why sometimes the compiler complains, because each variable also has an ownership. So you have one variable have one ownership. So if you want to pass the variable to other functions, you lose the ownerships if you are not using references or are not using other kind of. So that's why implicitly it makes you think about the memory.
Aware.
It has been really good design by default. Yeah.
Okay, okay. Okay, then I think that that is all. So thank you very much, Julia, for the amazing project and presentation. Thank you.
Thank you for inviting me.
You are the round of applause from the audience. Thank you. Cheers, bye.
Yes, thanks a lot, Julia. Thank you for answering my question as well. Yes, I think it was about the cargo.toml. So thank you about that. And dear attendees, now please take a moment, and there should be a small box in the chat where you should be able to rate the speaker. So please take a moment to rate the speaker, because at the end of the day, we're going to be rating the best speaker based on your votes.
Wow, great. So before the next speaker hits the stage, guess what? I think you know what's gonna happen.
Wait, again?
Yes. We have a prize quiz again. So yeah, because we still have some super swag box to give to you guys. So yeah, the winner will have a robotic developer T-shirt, coffee mug, and the stickers. So same. How does it work? And we will watch a 5-minute video about the robotics developer masterclass. And at the end of the video, you will see the question related to the masterclass. So the first person who answers correctly will win the swag box. So you may need to visit the page of the sponsor to get to the answers. So now let's watch the video, and the next speaker will come back in 5 minutes.
See you soon.